Hi, good morning, everyone. So,
Good
in
morning, sir.
the last lecture, uh, we have discussed about mean values theorem and inverse function theorem. Okay, so what is inverse function theorem? Abhay, what is inverse function theorem? What is the statement of inverse function theorem?
Yes, sir.
Do you remember inverse function theorem?
Sir.
So roughly speaking, then if f is bijective function, or f is a mapping from interval I to R and which is continuously differentiable function, and f dash is non-zero throughout the interval, and suppose then suppose f is differentiable on open interval AB, and let us assume that f dash x is non-zero throughout the domain, then its inverse function is also differentiable, and inverse derivative of inverse function is nothing but 1 upon f dash. So this is known as inverse function theorem. So what is Cauchy's mean value theorem? We have also discussed Cauchy's mean value theorem. So do you remember the statement of Cauchy's mean value theorem? Abhay,
ना सर नहीं याद आ रहा.
recall that Cauchy mean value theorem what does it tells us? F and g, suppose there are two functions f and g from closed interval AB to R continuous on open interval AB to R, they are differentiable. Also, let us assume that g dash x is non-zero. Derivative function g dash is non-zero for every x belongs to open interval AB. Then there exists C belongs to open interval AB such that FB minus FA upon GB minus GA is equal to F dash C upon G dash. So this is known as Cauchy's mean value theorem. This is a very important result. Why this is important? Because we will use this result to prove L'Hopital rule or L'Hopital rule. L'Hopital rule is a very important for finding the limit of function. Okay, so we will use this result to prove L'Hopital rule. So this is known as Cauchy's mean value theorem. Also, we have seen this thing. Suppose G from, let us say, closed interval AB to R continuous and non-zero function. Okay, and suppose at one point function takes positive value, then there exists delta greater than 0 or delta 1 greater than 0 such that for all x belongs to a minus delta 1 to x0 minus delta 1 to, sorry, around x0 plus delta 1 implies continuous here not g dash x, just gx is non-zero, implies gx is greater than 0. Here function, if f or g is non-zero function, then there exists neighborhood of that point throughout which f or g takes same sign. Okay, this result we have discussed in continuity. Okay, here we will take here gx not equal to 0 for all x in AB. We will use this result also. Also, we have seen that what is the meaning of limit x tends to a, gx equal to infinity, if and only if for every m greater than 0, there exists delta greater than 0 such that, let me take delta 2 greater than 0, such that for all x belongs to, or let me take in this way, for all x belongs to a minus delta to a plus delta minus a, this implies that gx is bigger than m. So for every m belongs to m greater than 0, you can find out some positive integer delta or positive number delta so that this happens. Let me take here delta 2. So far I have taken here delta 2. Okay, fine. So do you remember this result? Already we have defined this thing. So this is a definition of limit x tends to a, gx equal to infinity. Gx goes to infinity as x tends to a. What does this mean? Gx approaching to infinity whenever x approaches to a. Okay, what does this mean? If you take any number, sufficiently large number, so let us assume that m is any number which is very large number, then also you can find out some neighborhood of a such that for all x in that neighborhood, deleted neighborhood, gx can be made bigger than this m. Do you understand? Therefore, it's gx tends to infinity as x tends to a. So we will use all of these results in order to prove L'Hopital rule. Okay, so let me first state the L'Hopital rule. This is a very important result. Okay. So let me state L'Hopital rule. Fine. So this is a very important theorem. So already you know this rule. Okay, whenever you want to find out limit of function and of the form, limit is of the form limit x tends to a fx upon gx, and if you put this into 0 by 0 form or infinity by infinity form, what does this mean? F of a, if you put a in place of x, if f of a is 0, g of a is 0, then it is known as 0 by 0 form. Or if you put x equal to a, fx tends to infinity, if you put x equal to a, gx tends to infinity, then it is known as infinity upon infinity form. Whenever this type of situation occurs, you can apply L'Hopital rule. Provided f and g should be differentiable and g dash x is non-zero, then limit of this function is exactly equal to, what is the limit of this? F dash x upon g dash x, provided this limit exists. Do you remember? Why?
Yes, sir.
Okay, so you have studied this result in semester 1. So today we are going to prove this result by tools and techniques of analysis. Okay, fine. So let us see the proof. So first we consider this case. See, this is the statement. Let J be an open interval. Okay, you may take J equal to open interval AB or open interval XY or open interval CD, whatever. Let either A belongs to J or A is an endpoint of J. See, this is the situation. A may be in J or A is endpoint of J. Means J is of the form, you may take like this, okay, X A, or suppose let me take J is of the form J equal to, let me take CD. Suppose J is CD, where A is lies between C and D, or D equal to A also is possible. So J can be also taken C A. Okay, so either J A belongs to J or A is an endpoint of J. So this is the meaning of this. Note that it may happen that A equal to plus or minus infinity. See, A can also be infinity, plus or minus infinity, isn't it? Assume that F and G are mapping from J minus A to R, and which are differentiable. Here we have assumed that F and G both are differentiable. Gx is not equal to 0 and G dash x is not equal to 0 for all x belongs to J minus A. And limit x tends to A fx equal to limit x tends to A gx. This both have same limit, and the same limit is A. But A has only two possible values, either A equal to 0 or A equal to infinity. Okay, so these are the possible values of A. Assume that B equal to limit x tends to A f dash x upon G dash x exists. That is, we have here assumed that f dash upon G dash as x tends to A, this limit exists, and that limit is equal to capital B. Here also possibility is there that B equal to infinity or minus infinity. Then conclusion is this: limit of fx upon gx x tends to A, this exists, and this limit is precisely equal to B, that is limit f dash upon G dash. See, this is a very nice result. So here we have assumed that this limit exists, and fx upon gx may or may not exist. This limit, I mean, you cannot find out directly limit of this fractional function, but with the help of this you can find out limit. See, suppose, let me take one example. Limit x tends to 0 sine x upon x. See, if you put x equal to 0, so what is sine 0 away?
0.
And if you put x equal to 0, so here 0, so this is 0 by 0 form. And we know fx equal to sine x is differentiable, gx equal to x is differentiable. Okay, now therefore what is the limit of this function? You can say that limit of this function is limit x tends to 0 f dash x. F dash x means derivative of sine x. What is derivative of sine x? Cos x. And derivative of x is 1. So you have just left with limit x tends to 0 cos x. Now just put x equal to 0 in this limit, cos 0 is 1. So now you can say limit of sine x upon x, or limit of theta, sine theta upon theta, theta goes to 0 is equal to 1. So this is a application of L'Hopital rule. Okay, so this is a very important. So we cannot directly find out this limit, but from L'Hopital rule this limit is nothing but precisely equal to f dash upon G dash. Okay, and we know this limit exists. Already it is given in the statement, this limit exists, and that limit is equal to B. So this is the L'Hopital rule. This is a very important result for examination purpose and as well as exam application purpose, and this was asked too many times in the university examination also. So let us prove this result. Let us assume that first of all a equal to 0. See here there are two possibilities for capital A. Either a is 0 or a is infinity. So consider this example, sine theta upon theta, limit theta tends to 0. So if you put sine theta equal to 0 in this, so sine 0 is 0. Okay, so here this limit is 0. You understand? For this particular example, a is 0. So we will first consider this simple case a equal to 0. Assume that a equal to 0. A belongs to R, small a, it is finite number, and B is also finite number. So we are not taking B equal to infinity, A, small a. Okay, capital A is equal to infinity. Now set this. We take a equal to 0. Set f of a equal to 0. Okay, equal to g of a. What does this mean? A means here 0, sine 0 is 0. So here we assume that f of a is 0. So this is 0 by 0 form. Okay, so we have assumed that f a equal to 0 equal to g a. Now f and g are continuous on j. Okay, so let xn, so it is given that f and g are continuous. Since it is the f and g are differentiable, they are also continuous. Okay, so in this case, suppose we assume that f equal to 0, g equal to 0. What is my claim, by the way? What is our claim? Why? What we want to prove? Limit x tends to a, fx upon gx. We want to prove that this limit is equal to b. Here also it is given that limit x tends to a, f dash x upon g dash x. This limit is b. See, look at this. Assume that this limit is b, then prove that this limit is also b. Do you understand? This is our claim. Vaibhav.
Yes, sir.
Do you understand?
Yes, sir.
So, in order to prove this, see here our aim is to show that limit of this function fx upon gx as x tends to a is b. So we will use sequential criteria. So what we will do, I will take, see, we know that we will use this result. Limit x tends to a, fx equal to L, this limit is L if and only for every sequence xn from domain of f with xn not equal to a for every n belongs to n, and xn tends to a as n tends to infinity. This implies that fxn tends to L as n tends to infinity. So we will use this result. Do you remember this result, Abhay?
Yes, sir.
In the last lecture, in inverse function theorem, we have used this result. Okay, we said that limit x tends to fx equal to f if and only for every sequence xn from domain of f with xn tends to a and xn not equal to a implies fxn tends to L. So this is sequential criteria. So now look at this. Now I want to show that limit x tends to a fx upon gx is equal to b. So from where I should begin? What should I take? I should consider one sequence. Let me take Cn. Okay, so that Cn tends to A. Here Xn tends to, here X tends to A. Therefore, I have taken Xn tends to A. Okay, so now let me take, let Xn be any sequence in J minus A such that Xn tends to A, okay, and Xn tends to A. We will show that. Now see, look at this. Sequence is from J minus A. So Xn can never be A, Xn not equal to A for all A. So there are two possibilities. Either Xn greater than A or Xn less than A. Do you understand? Since Xn is not equal to A by trichotomy law, one of this is possible. Okay, now we show that in order to prove that this limit is B, we show that limit n tends to infinity fxn upon gxn, this limit must be equal to capital B. Do you understand?
Yes, sir.
So let me prove this. Fine. So already we have given that x tends to a f dash x upon g dash x, this limit is B. F dash upon g dash is limit B. Okay, not f upon, and f upon g we want to show that this is limit B. So somehow from f dash, what is the relation between f dash f and f dash g dash f and f g? See, look at this result, Cauchy's mean value theorem. This is nothing but relation between fb, fa, f dash, gb, ga and g dash. See, already we have here set fa equal to 0, ga equal to 0. So you can take this to be 0. So fb upon gb equal to f dash c upon g dash c. You can find out some c from open interval ab so that this is true. Okay, now I have two things, either xn is greater than a or xn is less than a. So suppose xn is greater than a, then what happen? And let me take a is less than xn, then this is the interval. So now I will apply Cauchy's mean value theorem either in this interval or in this interval. Do you understand? So by Cauchy's mean value theorem, you can find out there exists Cn corresponding to each xn. You can find out Cn between a and xn, or xn and a, between a and xn, whatever may be the case is, but Cn must belongs to, Cn must be between xn and a, such that, see, fb minus fa, b is xn, so fxn minus fa upon gxn minus ga, this equal to f dash cn upon g dash cn. Okay, already I have given that g dash is non-zero. See, g dash x is non-zero for all x belongs to j minus a. Now already we have taken fa equal to 0, g equal to 0. So what is the value of fxn upon gxn? This is equal to f dash cn upon g dash cn. Now let me say this to be 1. Now what is limit of cn? Cn is a sequence between a and xn. So for simplicity, let us assume that, without loss of generality, let me assume that xn less than a. Okay, then Cn is a sequence C. This is xn, this is a. Cn is a sequence between xn and a. So xn less than Cn less than a. Now take limit n tends to infinity. This is less than or equal to limit n tends to infinity Cn less than or equal to limit n tends to infinity a. Now this is a constant sequence, so this limit is a. Now what is limit of xn? Abhay,
Sir.
what is limit of xn? Already we have taken that xn tends to
A.
yes, yes. So limit n tends to
A.
infinity xn equal to a. So now a less than or equal to this is less than or equal to. Therefore, by Sandwich theorem, you can say that limit n tends to infinity Cn equal to a, and Cn is not equal to a, isn't it? Because Cn is strictly less than a. The reason is this. Okay, now I have found the sequence Cn tends to a, Cn not equal to a for all n belongs to n. Also, it is given that limit of f dash x upon g dash x. What is limit of f dash x upon g dash x? This is equal to b. It is given. See, it is given that limit of f dash x upon g dash x is equal to b. So now look at this. I have found a sequence Cn which tends to a. Okay, and since this has limit b, what is the limit n tends to infinity f dash Cn upon g dash Cn? Can anybody say? Vaibhav, what is the value of
Yeah.
limit n tends to infinity f dash Cn upon g dash Cn? What is the limit of this sequence? Vaibhav?
B.
Yes?
B, sir.
B, very good. Why it is B? Because I have found a sequence for which Cn, I have found a sequence Cn for which Cn tends to a, Cn not equal to a, and already it is given that limit of f dash x upon g dash x is equal to b as x tends to a. So due to this reason and this reason, you can definitely say that limit n tends to infinity f dash Cn upon g dash Cn equal to b. So now, by 1, what can you say about limit of fxn upon gx1? Can anybody say what is limit of? Abhay, since these two are
B, sir.
same and this has limit b, what is the limit of this?
B.
B, yes. So therefore, for every sequence xn belongs to j minus a with xn tends to a implies as n tends to infinity implies fxn upon gxn tends to b. So therefore, by sequential criteria of limit of function, you can say that limit x tends to a fx upon gx is equal to b. So the first case we have proved. See, this was our claim. We want to show that limit x tends to a fx upon gx equal to b. Our aim is this, and we have proved. So do you understand?
Yes, sir.
Now let us consider second case. So now second case is this. Let us assume that a equal to infinity. Here I have taken that capital A equal to 0. Now let us look at the case a equal to infinity. Okay, now consider this function. Define h from j to r is equal to hx is equal to fx minus b into gx. See, b is, what is b? B does not stand for Bhavin. Okay, Vaibhav, B is
Okay,
nothing
sir.
but limit of fx upon gx, f dash upon g dash. It is given in the statement that limit as x tends to a, f dash x upon g dash x is equal to b. So I have defined, with the help of f, g and b, I have defined new function h, and hx is equal to fx minus b times gx. Since f and g are differentiable, h is also differentiable and continuous. What is h dash x? F dash x minus b is constant, so it can be taken outside of derivative. Do you understand?
Yes, sir.
Fine. Okay. Since I can divide throughout this equality by g dash x, as it is given that g dash x is non-zero. Clear? Now let me take limit x tends to a. Clear? So apply algebra of limit. Limit of fx plus gx is equal to limit of fx plus limit of gx. Since b is constant, limit of b is just b. So now can anybody tell me what is limit of f dash upon g dash? What is limit of f dash upon g dash?
B. B, sir.
So just put this is equal to b. So what is the answer?
0.
Yes. So limit as x tends to a, hx upon h dash x upon g dash x is equal to 0. Okay. See, what is the strategy? What is our claim is this? What is our claim? We want to show that keep this thing in your mind. We want to show that limit x tends to a, fx upon gx, this is equal to b, isn't it? Or that is, also you can show that just bring b on left side. It is sufficient to show that limit x tends to a, fx upon gx minus b, this limit must be equal to 0. Okay, do you understand?
Yes, sir.
So now see, so look at this. Now just divide this inequality by gx. It is given that gx is non-zero, so this is nothing but fx upon gx minus b, isn't it? If you divide this function h by g, then you will get this. So if you take limit x tends to a, we want to show that fx upon gx has limit b, or this has limit 0. So it is sufficient to show that limit hx upon gx, this must equal to 0. Do you understand? So if we can show that limit x tends to a, hx upon gx equal to 0, then hx upon gx is nothing but fx upon gx minus b. Therefore this has limit 0, and hence limit x tends to a, fx upon gx is equal to b. So it is sufficient to show that limit hx upon gx is, but this is nothing but limit x tends to a, hx upon gx. So it is enough to show that limit x tends to a, hx upon gx, this is equal to 0. So now tell me, from where we should begin? I want to show that this limit is 0. We will use epsilon delta definition of limit. So from where we should begin?
Epsilon greater than 0.
Yes, very good. So let us take epsilon positive. So for simplicity here I will just use half neighborhood. Okay, we will just consider right limit. ये हम लेफ्ट लिमिट यहाँ पे कहीं पे कंसिडर नहीं करेंगे. वी जस्ट आई विल शो दैट लिमिट एज x टेंड्स टू a प्लस hx अपॉन gx इज 0. सिमिलरली यू कैन शो दैट लिमिट x टेंड्स टू a माइनस hx अपॉन gx इज इक्वल टू 0. लेकिन हम वो लेफ्ट लिमिट वाला यहाँ पे नहीं यूज करेंगे क्योंकि अदरवाइज प्रूफ बिकम्स टू मच लेंथी. Okay, so let us consider epsilon greater than 0. Okay, and we find out some delta positive so that whenever x is lies between a to a plus delta, hx upon gx is less than epsilon. So we find out delta 3 greater than 0 such that for all x belongs to a plus delta 3 implies hx upon gx, this must less than epsilon. See, this is your point A. We are trying to evaluate limit as a limit at point A. So this is point A. A plus delta 3 is somewhere here and a minus delta 3 is somewhere here. Now I am saying that we will consider just right limit. So we will just approach a from right side. So whenever your x is lies between a to a plus delta 3, your hx upon gx must less than epsilon. Do you understand? This is our aim. I want to find out delta 3 so that something happen. Why I have given name delta 3 वो आपको बाद में पता चलेगा. ठीक है, ये समझ में आया यहाँ तक?
हाँ सर.
Fine. So now look at this. Epsilon is positive. Now since epsilon greater than 0, gx is positive and g is continuous. Okay, and limit as x tends to a h dash x upon g dash x. What is limit of this? See, just few minutes ago I have showed that limit x tends to h dash x upon g dash x. This limit is 0. So this limit is 0. अभी ये क्या कैसी सिचुएशन है पता है आपको? सर्वोत्तम है ना, वो उसको भूख लगी है, शाम के 7 साढ़े 7 बजे वो नवसारी में कहीं पे घूम रहा है और रेस्टोरेंट के आगे से पसार हो रहा है, भाजी पाव का रेस्टोरेंट है, तो उसको क्या होगा? क्या मन होगा उसका? क्या मन करेगा?
खाने का.
हाँ, खाने का मन करेगा, लेकिन खाना खाने के लिए उसके पास क्या होना चाहिए?
पैसे।
हाँ, तो ये एप्सिलॉन है ना, वो पैसे है, और ये रेस्टोरेंट है, तो वो जरूर खाना खाएगा क्योंकि उसको भूख लगी। सो क्या होगा एज अ रिजल्ट, there exists some delta 1, let me say now delta 1 greater than 0, such that actually there are two deltas, delta 1 and delta 2, यहाँ पे दो डेल्टा मिलेंगे, लेकिन मैं एक से ही काम चला लेता हूँ। such that for all x belongs to a plus delta 1, this implies that gx is positive throughout this neighborhood, and second thing is this, modulus of h dash x upon g dash x, this is less than epsilon by 2. Why this is less than epsilon by 2? Since this limit is 0. Actually you should write here h dash minus g dash minus 0 less than epsilon by 2, but 0 नहीं लिखेंगे तो भी चलेगा, ठीक है। h dash upon g dash is less than epsilon by 2. So do you understand? I have not considered full interval, I have just taken half of the interval, this much portion I have considered. Do you understand? In place of delta 3 I have taken delta 1. तो आपको ये लगेगा कि सर दोनों दो डेल्टा 1 ले, यहाँ पे g1 g कंटिन्यूअस है और g पॉजिटिव है, तो पहले g के लिए आप डेल्टा 1 भी लेंगे, फाइंड कर सकते हैं, और लेट मी से डेल्टा, और ये इसके लिए क्या फाइंड करेंगे, डेल्टा डे, सो दैट g becomes positive from a to a plus delta, and this is less than epsilon by 2 for a to a plus delta dash. तो दोनों साइमल्टेनियसली मुझे लेना है, तो क्या कर मेरा डेल्टा 1 होना चाहिए, व्हाट शुड आई चूज, डेल्टा, सो दैट बोथ ऑफ दिस आर ट्रू, क्या लेना चाहिए, डेल्टा 1,
मिनिमम अप टू।
यस। तो वो स्टेप, दो स्टेप लिखने की जगह मैंने एक स्टेप से काम चला लिया है, ठीक है, अदरवाइज प्रूफ बिकम्स टू मच लेंथी। ओके, डू यू अंडरस्टैंड?
यस सर।
Fine. So let me say this to be 2. Already I have given number 1. Fine. Now apply Cauchy's mean value theorem on a to a plus delta 1. Now I have delta 1. Now by Cauchy's mean value theorem, if x belongs to a plus delta 1, there exists cx. See, look at this. Here a to b, Cauchy's mean value theorem, the statement of Cauchy's mean value theorem is something like this. You can find out c from open interval ab. Okay, so here in place of a I have a, and in place of b I have a plus delta 1. तो ये मुझे cx पॉइंट मिलेगा, वो कहाँ से मिलेगा, इंटरवल a to a प्लस delta 1, such that f h x minus h a plus delta 1 upon c. Let me write down here x. I am applying c. I have taken x from a to a plus delta 1, and I have considered this. This is your a, this is your x, this is your a plus delta 1. So I have applied Cauchy's mean value theorem in which interval, from x to a plus delta 1. So there exists cx between x to a plus delta 1, such that this is gx minus, what should I write here, g of a plus delta 1 is equal to, what should I write here, h dash cx upon g dash cx. Do you understand?
Yes sir.
So I have applied Cauchy's mean value theorem in which interval, from x to a plus delta 1. So You can also write in this way, h a plus delta 1 minus hx upon g a plus delta 1 minus gx, but both are same, isn't it? Fine. So now your cx is somewhere here. Cx is between x to a plus delta 1. Okay, fine. So now let me say this to be equation number 3. Now look at 2 and 3. Now if your x is from a to a plus delta 1, that is if your x is between a to a plus delta 1, then h dash x upon g dash x is also always less than epsilon by 2. Now your cx is somewhere here. Cx is between x to a plus delta 1, so definitely cx must lies between a to a plus delta 1, isn't it? So what can you say about h dash cx upon g dash cx? This is subset of a to a plus delta 1 by 2 and 3 h dash modulus of this hx minus h a plus delta 1 upon gx minus g of a plus delta 1 is equal to, value of this is nothing but h dash cx upon g dash cx, and this must less than epsilon by 2 by 2. Why you can write this less than epsilon by 2? Since cx belongs to a plus delta 1. Whenever your x is between a to a plus delta 1, your h dash x upon g dash x is less than epsilon by 2. Do you understand?
Yes, sir.
So now put this together. Therefore, for all x between a to a plus delta 1, this implies that hx minus h of a plus delta 1 upon gx minus g of a plus delta 1, this is less than epsilon by 2. Let me say this to be, which number I should give? 3, 4. Okay, fine. Now it is given that what is limit of a, the limit of gx as x tends to a equal to a, and we have assumed that, see, look at in the statement, it is given that limit x tends to a gx equal to a, and we have assumed that a equal to infinity, capital A equal to infinity. So what is the limit of gx as x tends to a? This is infinity. Okay, fine. And also g of, what can you say about g of a plus delta 1? By the way, g a plus delta 1 नेगेटिव होगा कि पॉजिटिव? यहाँ पे देखिए, from 2, whenever your x between a to a plus delta 1, what can you say about gx?
Greater than 0.
Yes, so at end point a plus delta 1, g of a plus delta 1 is positive, isn't it?
Yes, sir.
Okay, since this limit is infinity, for m equal to g of a plus delta 1 greater than 0, there exists delta 2 greater than 0 such that gx is greater than m equal to g of a plus delta 1 if x belongs to a to see, a to a plus delta 2. So I have found another delta. Why I can write in this way? Because limit x tends to a, gx equal to infinity. What does it mean? For all m greater than 0, here in place of m, I have g of a plus delta 1. For all constant m greater than 0, you can always find out some delta 2 such that whenever your x is in a minus delta 2 a plus delta 2, your gx must be greater than m. Do you understand? So here I am considering just right limit. Due to this reason, I have taken a to a plus delta 2. Okay, now here also I can assume delta 2 is less than delta 1. Otherwise, you need to take its minimum. Here you may choose delta 2 greater than 0 so that delta 2. Why this is possible? If this is not possible, I will take minimum of this delta 1 and delta 2. Okay, so this is always possible to take delta 2 so that delta 2 less than delta 1 and delta 2 is greater than 0 so that this happen. So now just bring g a minus delta 1 on left side. So 0 less than gx minus g of a plus delta 2 delta 1. This is less than gx for all x belongs to a plus delta 2. So this picture is something like this. This is your point A, this is your point a plus delta 2, this is your point a plus delta 1. So this much distance is delta 1 and this much distance is delta 2. Do you understand? So now if your x is between a to a plus delta 2, obviously your x is between a to a plus delta 1 also. Okay, between a to a plus delta 2, then x is also lies between a to a plus delta 1. Hence this is true. Do you understand? Fine. So now let me say this to be phi. Now consider this hx minus h of a plus delta 1 upon gx. hx minus h of a plus delta 1 upon gx. Okay, so this is always less than hx minus h a plus delta 1. I have kept numerator as it is and I am subtracting something from the denominator, gx minus g of a plus delta 1. So what is the relation between these two quantity? This is always bigger than this one because I am subtracting here something from gx. Do you understand? ये क्या कर रहा हूँ मैं, डिनोमिनेटर को छोटा कर रहा हूँ तो ये पूरा नंबर क्या हो जाएगा, बड़ा हो जाएगा इससे as compared to this. Do you understand this step?
हाँ सर.
और ये क्यों? क्योंकि gx minus g of a plus delta 1, this is always positive. Fine. So now consider, now this is less than hx minus h a plus a plus delta 1. This is always less than epsilon by 2, isn't it? Whenever your x is between a to a plus delta 1. So now I can say this is less than epsilon by 2 if x belongs to, see, when you can say that gx minus a ga plus delta 1 less than gx, whenever your x is between a to a plus delta 2, and when you can say this is less than epsilon 1 whenever x is between a to a plus delta 1. So what interval I should consider here, a to a plus delta 1 or a to a plus delta 2? Vaibhav?
Yes sir.
Here what should I write, a plus delta 1 or a plus delta 2?
A plus delta 2.
यस, ए प्लस डेल्टा टू लेना चाहिए, क्योंकि ए प्लस डेल्टा टू में एक्स लेंगे तो ऑटोमेटिकली दैट विल बी इन ए प्लस डेल्टा वन, इजंट इट? समझ में आ रहा है जो मैं कह रहा हूं?
हाँ सर।
तो ये क्या हुआ, फॉर ऑल एक्स बिलोंग्स टू a plus delta 2 implies hx minus ha plus delta 1 upon gx is less than epsilon by 2 whenever your x is between a to a plus delta 2. Let me say this to be 6. Okay, now it is given that limit x tends to a gx equal to infinity. So this implies that what is the limit of 1 upon gx? 1 upon gx tends to 0 as x tends to a, isn't it? Do you understand? If you take reciprocal of infinity, that goes to 0. So now apply the definition of limit, that is limit x tends to a. Let me therefore you can say limit, what is limit of, let me multiply this number by h a plus delta 1. h a plus delta 1 is constant upon gx. Since this is 0 as x tends to a, 1 upon gx is 0 and this is a constant number, so this limit must be equal to 0. Do you understand why 1 upon gx has limit 0? Because gx tends to infinity. Actually this limit is a and we have assumed that a is infinity. Okay, so now again this limit is 0 and epsilon is positive. तो क्या फाइंड करेंगे आप? You can find out therefore there exists delta 3 greater than 0 such that delta 3 less than delta 2 and h of a plus delta 1 upon gx this less than epsilon by 2 for all x belongs to a plus delta 3. समझ में आ रहा है? देखिए, this is your a, this is your a plus delta 1, sorry delta 3, this is a plus delta 2 and this is a plus delta 1. So do you understand? Abhay,
Yes sir.
delta 3 I have chosen
Yes,
less
sir.
than delta 2. Otherwise I need to take minimum of all these three. तो ये सिचुएशन में मैं गया नहीं हूँ, डायरेक्टली मैंने चूज कर लिया डेल्टा 3 इज लेस देन डेल्टा 2. So if your x is between a to a plus delta 3, you can definitely say that h of a plus delta 1 over gx is less than epsilon by 2. Now let me say this to be which number I should give, 7. Fine. So now let me consider x from a to a plus delta 3. So therefore for x belongs to a to a plus delta 3. a to a plus delta 3 is contained in a to a plus delta 2, which is contained in a to a plus delta 1. So if your x is between a to a plus delta 3, then obviously x is in this interval as well as in this interval. Okay, so now let us consider hx upon gx. Actually, what is our aim? We want to show that hx upon gx is less than epsilon whenever a x is between a to a plus delta 3. ये आपको समझ में आया मैंने क्यों यहाँ पे डेल्टा 3 लिया था वैभव?
हाँ सर आ गया।
So now I have taken x from a to a plus delta 3 and now I want to show that hx upon gx is less than epsilon. So in order to show this is less than epsilon, what should I consider? I should consider this ratio hx upon gx. Okay. So and its modulus. So this is equal to, you can write in this way, hx minus a plus delta 1 upon gx. So you need to add a plus delta 1. Okay. So this gets cancelled and you will get hx upon gx. So this is further less than or equal to hx minus ha plus delta 1 upon gx. I have not written here mod because gx is positive, and here mod of ha plus delta 1 upon gx. Do you understand? I have applied just triangle inequality. So hx minus ha plus delta 1 upon gx, ha plus delta 1 upon gx. So now what can you say about this ratio hx minus ha plus delta 1 upon gx? Hx minus ha plus delta 1 upon gx. This modulus is always less than epsilon double, epsilon by 2. But whenever your x is between a to a plus delta 2. So now look at x. X is in this interval, therefore it is also in this. So this can be made less than epsilon by 2. Now when this is true, ha plus delta 1 plus gx. Now look at this. This is less than epsilon 2 when x between a to a plus delta 3. And already I have taken x is between a to a plus. So by putting this together, you will get epsilon. So now look at this. I have begin with epsilon greater than 0. So now let me put all this together. Where is my epsilon? Yes, this. I have begin with this epsilon positive, and I have found epsilon greater than 0, there exists some delta 3 greater than 0 such that for all x between a to a plus delta 3, this implies that hx upon gx is less than epsilon. Therefore, you can say that limit x tends to actually a plus, but I will write just a. This limit is, what is the value of this limit? Why? Yes?
B.
Here 0 है यार, ऐसे कैसे आप बताएं, यहाँ 0 है ना, तो लिमिट क्या होगी इसकी hx upon gx की? अबे यार भूल गए यार डेफिनेशन. व्हाट इज मीनिंग ऑफ लिमिट x टेंड्स टू a fx इक्वल टू l? व्हाट डज दिस मीन? याद नहीं है? ये सब याद रखना है कि भूख लगी है.
हाँ सर.
fx minus l, this should less than epsilon. So this is your fx. Fx is nothing but hx upon gx, and l is nothing but 0. So therefore you can say that limit x tends to hx upon gx is 0. Now put value of hx. What is hx? fx minus b times gx. So limit x tends to a fx upon gx is equal to b. Hence the theorem is proved. Okay, other cases are left to the reader. So this is the Hopital rule. समझ में आया कि नहीं आया?
हाँ
Go
सर
through the
आ
proof.
गया.
Go through the proof at least 4 to 5 times. How many times? 4 से 5 बार ये प्रूफ देख
4
लीजिए,
to
समझने की कोशिश कीजिए. हम आई हैव जस्ट कंसिडर हाफ इंटरवल. ये देखिए, लेकिन वी हैव यूज so many tools and technology tools and techniques of analysis. समझ में आ रहा है? ये डेल्टा एप्सिलॉन ऐसे वैसे नहीं लेने, जहाँ टेक्निकली जो प्रूव हो ना तभी ये चलता है. सो वी स्टॉप आवर डिस्कशन. ओके, लेट मी डाउनलोड दैट एंडर्स. समझ में आ गया कि नहीं थ्योरम?
हाँ सर.
Yes, sir.
हाँ, प्रूफ तो इजी है, लेकिन सारे रिजल्ट्स पता होना चाहिए आपको. कोशिश मीन वैल्यू थ्योरम एंड रिमेनिंग ऑल द रिजल्ट्स. सो वी स्टॉप आवर डिस्कशन हियर. ओके, सो गुड बाय.
Goodbye sir.
Goodbye, sir.
ये तो एम જ હોય.